welcome back. So I'm delighted to be here hosting a panel discussion on hitting net zero. And I've been joined by a number of experts in the field of aerospace. If we turn to the panellists, I have with me Professor Simon Weeks from the ATI, Brian Yutko from Boeing, Chris Hughes from Spirit, Chris Gear, who was our project director on FlyZero, and also Mark Bentall from Airbus. Thank you very much for joining us today. I'd like to start, if I can, with a broad question to you all. From your perspective, what are the biggest challenges to achieving net zero? And perhaps I can ask Simon for you to start with that.
Thanks, Sophie. I'm Simon Weeks, Chief Technology Officer of the ATI. In my mind, there are several big challenges. First, technology. There's the technologies to make aircraft much more energy efficient than they are today. And that helps whatever the energy sources that you use. It's accelerating the availability of alternative low carbon energy sources such as SAF and hydrogen. And it's getting the economics right around those things. The technology is going to be a long process to acquire. It's going to cost a lot of money. That needs to be financed, as does the commercialization of that technology, and getting the infrastructure in place for the production and distribution of alternative energy sources such as SAF and hydrogen.
Okay, so Brian, if you could expand on that from your perspective, do you think that those are all of the challenges as an airframer? What are you struggling with at the moment?
Yeah, thanks. I'm Brian Yutko. I'm Boeing's Vice President and Chief Engineer for Sustainability and Future Mobility. And so the way that I think about it, so I'm an engineer, so I try to think about this very practically. Net zero. The way that I think about this is really practically achieving the objective behind net zero, which is eliminating the environmental impact. And eliminating the environmental impact comes from two different dimensions. It comes from full life cycle accounting of all of the impacts of how we're producing our airplanes and where we're getting our energies from on one dimension. And on the other dimension, it comes from the total climate impact. So things like CO2 and non-CO2 and so on. So in order to actually practically achieve what we want, which is eliminating climate impact, we have to make a difference in those two dimensions. So full life cycle accounting, total climate impact. And so if you think about those two dimensions and you think about the challenge that we're faced with, you know, if you do an accounting of the scopes of emissions for an OEM like Boeing, we've recently released this in a report in one of our recent reports. Our scope 1 and scope 2 emissions are relatively small. That doesn't mean that they're not important compared to our scope 3 emissions, which are products in use. Our scope 3 emissions are about 99% roughly of total emissions when you add up scope 1, 2, and 3. So that means if you want to solve the problem, you have to solve products in use. And then if you look at the emissions of products in use and you actually account for where are they, half of the flights in the global air transportation system is 1,000 kilometers or less. But they only represent about 15% of the total fuel consumed globally. So 85% of the emissions come from flights that are longer than 1,000 kilometers. So if we think about the tools to go about solving that, we've kind of put that into 4 pillars, and we could talk about them, throughout this panel. But we think about fleet renewal, making our airplanes more efficient with each generation, operational efficiency, flying airplanes more efficiently tomorrow than today, renewable energies, and that's things like, again, the full life cycle accounting of sustainable fuels, hydrogen, all the rest, and then advanced technologies. And we can get into it as we have a discussion here about the contributions of each of those.
Thank you. Mark, reflecting on that, obviously, you're looking at it from a European perspective. Is the same hold true here?
Thank you, Sophie. Yes, so Mark Bentall, I head the Research and Technology Program for Airbus. Yes, you're exactly right, and Brian has laid it out pretty clearly. So maybe just to expand a little bit on some of those points. So if we're looking at those aircraft efficient technologies, then if we look, you've got the propulsion side, what's already been mentioned on hydrogen combustion or sustainable fuels. There's also other technologies which increase complexity and make the problem more challenging with like hybridization into that mix. If we look at on the stride and the aerostructures, then see one of the most important parts is the area where you're considering different span or structures or control technologies. So there's a lot of different technologies in those topics, as has already been alluded to. And that's just one of those pillars that Brian mentioned. So again, it goes deep, it goes into a lot of different areas. And all of that needs to be put into the mix.
Okay, thank you for that. And Chris Gear, I'm just going to turn to you because in the reports that you were responsible for producing earlier this year, you looked a lot at some of the gaps that exist currently in order to be able to take us towards 2050. Particularly, I'm thinking in terms of climate science. What are your views on those big challenges that we're facing?
Thanks, Sophie. So I'm Chris Gear. I was the FlyZero project director for the ATI. I think what people have been just saying, I find all really interesting, absolutely nail on the head. I do feel that one of the key challenges that we all face is this international collaboration, and how do we bring together all these individual ideas and create the global aerospace community that we know today, which is a very mature community and has very sort of strict safety and certification requirements. So I see some of the challenges that is going on is that, there are lots of ideas out there, lots of new solutions. So as Simon said, lots of need for technology investment, but also lots of need for investment in academia and also in global collaboration to create the integration. And probably one of our big challenges is going to be that the oil and gas industry are really needed to help support the aviation industry to bring this across and actually make it achievable. The big worry, though, is that, hydrogen and SAF are both needed and therefore both demanding investment. They have different time zones in terms of when they come on stream, but you need to do both now, which is one of the key findings from FlyZero. So it's a challenging time, but actually I think it's probably the most exciting time I've seen in aviation at the moment over my 40-odd year career, because there's so many changes there and possible, and so many connotations to answers and solutions that we really need to accelerate and get on and do some of these things, because the biggest probably churn that we have in the aviation industry is we've become a little bit slow at implementing new ideas because of all the safety and certification requirements, quite rightly, but we need to find ways of streamlining and accelerating.
Yeah, and I think one of the things you're driving at there is the complexity of the challenge, because we're heading towards net zero, but actually in a number of areas we still don't have the full understanding of the pathways or indeed some of the data sources that we might require to maybe have some more clarity over what that route looks like.
Yeah, there's still a lot of open questions around climate science, as you pointed out at the beginning of this conversation, where a lot's happening up in the atmosphere. We found lots of very interesting facts and figures, but there's still a lot more work needed. So it is very much a complicated equation, and it's going to require the brains of the whole community to solve them. And we've got to find ways of collaborating and not just going off on our own, which is going to be probably a bigger challenge.
Oh, Brian, you're on mute. Sorry, carry on.
Oh, yeah, sorry. I just want to second the point there on academia, which I think is extremely important. And I think in the UK in particular, the Whittle Lab, led by Rob Miller, is doing some really tremendous work. I think that the academic community just around the globe has so much to add to this. Obviously, that community won't be making airplanes in the end of the day, but they have critical insights into developing the roadmap and also studying things like non-CO2 effects and all the rest, and just really starting to piece together the science. So I just want to second the point on academia there.
Thank you. And Chris Hughes, I'm going to bring you in at this point. You're looking as a global company at the issues of sustainability, and you were also part of the FlyZero team. So how have you taken your experience there back into your company, and has it changed your approach towards sustainability?
Hi, Sophie. Yeah, Chris Hughes, Head of Product Sustainability at Spirit. Yes, we certainly have brought in back the learning from that 15-month challenge. And as the panelists have said, we're looking at it in different pillars. So firstly, looking at the production that we have today, and how do we set roadmaps for each of the production lines that we have to further make them more sustainable. Looking at reusing offcuts of material. I was having discussions just this week about how do simple things like how do we recycle the tins that resin are delivered in. Actually putting those in landfill isn't the answer. We use so many of them. So there's lots of things to tackle just from the production side of things. But then looking more broadly and looking at the energy systems, that we've studied. I think that the tech is the key. Is developing the technology and doing that in the coming beginning in just the coming few years to set us on the right trajectory. Otherwise, we won't get there in time. And that tech demonstrated, I think, at the right technology levels will then give the broader ecosystem confidence in the direction so that they can come online and we can develop the airport infrastructure, the energy provision. So yeah, at Spirit, we're starting to look now and change our R&D approach so that we're playing our part in developing that tech and pushing on the technology.
Yeah, and I think it's quite interesting because when we talk about net zero, we often just talk about the emissions in terms of flight, but actually this is about through life emissions and also about being a net zero industry. And I think, Chris, it was yourself who talked actually about this is quite a traditional industry, and it may be that we need to be a bit disruptive in order to make the kind of change required in the timescales required. I just wonder, Mark, whether you have any kind of reflection on that.
So yeah, thanks. So in our, you're right. It's far more. It flows. The sustainability topic flows across all areas of the business, not just in the flight part. So we have to consider the full life cycle, not just of the aircraft, but of the fuels as well. Obviously, that's a key part. But there's the full life cycle of the product. So even when we now go through our portfolio and our technology choices, we do the circularity assessment as part of our key sort of selection criteria to make sure that we are picking the right technologies, not just because maybe it's a weight, but also because it brings other circularity benefits, maybe in the energy, in the consumption, in manufacturing, or in the amount of waste, as has already been mentioned in the manufacturing, or even in the reuse and recycling. So it is a full cradle to cradle consideration that we have to bring in every piece of the portfolio.
Okay. And do you think, Brian, Boeing, all the companies actually that we've got on the call are global, they're huge. Are you able to be disruptive enough in the market, do you think, to rise to the challenges of hitting net zero 2050?
Well, I think so. I think if you look at, I should say, I love that question because it gives me a chance to mention my favorite airplane, which is the Boeing 367-80, which in 1957 created the industry that we're talking about now. And that was a bet the company moment to build a prototype airplane to show the value of jet transportation effectively. And so I think we've done this before in so many other dimensions. We're very confident in our ability to define the future of flight. I think that what's really fun about this moment is that we have these incredible opportunities to collaborate with what might traditionally be competitors in some spaces where there are, let's say, shared interests in driving towards interoperability of the system to make it more sustainable and so on. but we also have the ability to differentiate from the standpoint of competing on products and product, competitiveness and differentiation of the features. And so I've mentioned this before, but I just fundamentally think that this is a renaissance for aerospace engineers, and I think that you're going to see companies like Boeing and Airbus and many others just operating around the world to establish capabilities in country where there's unique kind of differentiating capability and interest to work in those domains. And yeah, I mean, I think that this industry is going to reinvent itself and meet these goals. I feel very confident about that.
Thank you. Yeah, Mark, do you want to come in?
Yeah, maybe I can just also reflect on that. This is driving quite a lot of excitement within the technical community, because it is an opportunity, just as has been said, to really drive for new solutions and new challenges. So it is correct. We share a common understanding of the landscape, and we've mentioned the academic side. We need to enrich, we need to improve that, we need to support the academic environment to improve on that analysis. So we can share that, and that's very healthy to do. But also within our own engineering teams, there's a lot of excitement to be working here, to be in this moment. So it is a very good time to be in this industry from that perspective. We will see new designs, new solutions coming into existence, and that's where we will differentiate and compete.
Yeah.
And can I just add that on FlyZero, that is exactly what we found with the people, the enthusiasm from all the secondee companies that put people into FlyZero. They were completely on the page about we need to reinvent and find sustainable aviation. And because of that energy and enthusiasm, they really drove some fantastic solutions. So I believe the people are in the community, but it's just trying to get them there and help them to drive those solutions.
Yeah. And it's an interesting question, actually, because aerospace is still viewed externally as a polluting sector, but actually the work that's going on to go towards net zero, to make those really substantive changes, is very exciting. And I think, people talk about this as potentially being revolutionary. We're not talking about evolution here. And I think that actually there's a really interesting story to tell, and hopefully panels like this, we're able to do it. But I just want to bring Simon Weeks in here, because you've just published the ATI technology strategy, and you talk a lot about collaboration and partnership. But you also say within it that both SAFs and hydrogen are going to be critical to this journey. Now, a lot of people seem to talk about SAFs and hydrogen like it's a binary choice, but you're obviously not saying that. So can you talk a little bit about that, please?
Yeah, I think what we're in is a process of transition. It's transition to much lower, carbon generating forms of flying ourselves around, and SAF and hydrogen are, I think, both key elements of that story. The whole fleet will not switch overnight. We've got a market out there, and the world at the moment is moving at different pace, depending where you are in the world, and towards a lower carbon future. And we need to recognise that and work out, if you like, the fastest way of transitioning to a much lower carbon future. But recognizing that different people move at different speeds. You've got the way the market works as well, which is a constraint on the speed at which we can progress. But from the work that the ATI have done, and we've backed this up with some quite comprehensive modelling work, we see that both are essential to getting to net zero, and we need to move faster. That's the other key thing.
So both are essential, but actually both have their challenges. Brian, do you want to come in?
Yeah, I do. I think this is a really important question. And the way that I would answer is it's SAF and other things. It's SAF and. That's very important. It's not an or. Because if we do not scale sustainable aviation fuels many hundredfold from the volumes that exist today, even up to 1,000-fold, we will not meet our goals. Period. So it's SAF and then the and is the fun part, because that's where all of the additional technologies come in, where all of the hydrogen concepts come in, it's where electric concepts come in. It's where all the innovation really is. But we really can't lose the point, which is, even in the, we've modeled this, and I really appreciate the modeling work done by the FlyZero and the recent, it's outstanding report. We've modeled this as well, and under any scenario of the uptake of those advanced concepts, we know that we need somewhere between many hundred-fold increase to 1,000-fold increase. So there's no choice. We have to scale SAF, and then we have to do these other things. And the other things are where the fun debates will be. But the first part, non-negotiable.
Absolutely. And actually, if we can then run with this a little bit further, what are the challenges to that scale up then? Because you're presumably able to give a demand signal, but how are we going to get the scale up that's required? Sorry, I'll put that to you, Brian, and then we'll...
Yeah, I don't know if that one was for me, but I'll say, we've been supporters of various kind of policy types around the world, which sometimes are called the carrot, obviously in the US, the blender's tax credit and some other things, sometimes of the stick variety, sometimes in Europe related to mandates and even combinations thereof in various other regions around the world. Those are all important in terms of creating the incentives to ultimately, provide investment into this space, to show that this is an investable domain where the demand is going to actually materialize in the future. These are long lead investments in order to do this. So I think all of those policy mechanisms are extremely important.
Okay. And from a European perspective, Mark, how do you think the scale up is being approached here? And do you see similar challenges?
Yeah, I mean, the challenges are exactly the same. It's a global market. So there are, the important thing is that when we do talk about things like incentives and that, it needs to be recognized on a global basis to make sure that that is done in a fair and sustainable way for such a global market. It is clearly a demand there. We need to take into account all of the different routes. There are many different pathways to SAF. We also need to get to SAF standardization for different sorts of, and obviously we all have a real important interest to make sure we have the aircraft. So we already, as we well know, have the 50% blend capability today. And we are, I think, all targeting aircraft to be 100% SAF by 2030. So I think we're all pretty well aligned on that. Exactly as it said, lots of pathways to get to the SAFs, lots of work to do on the standardization, lots of important to get the investment to make sure it's seen as an attractive place for people to invest, make sure that we've got the appropriate feedstocks for those different routes, and then supporting all of those. Ultimately, the ambition is to get to the power to liquid at some point, and there has to be a route to get there. So that's an important pathway, but there's going to have to be an adoption of different pathways over time, and that will take some time.
Okay, and I think that's really important that both of these technologies that are being talked about are critical. But you're absolutely right. In the short term, the answer is SAF. And when I say short term, that's in aviation terms. So, that's out beyond 2050, really. We need SAFs, but then potentially we need to be looking at some of those zero carbon technologies. So I think I'll just ask Simon to just say a little bit about the technology strategy and how you have described the three technology areas that you believe investment's required.
Yes, in my mind, those three key areas. First off, what we call ultra-efficient aircraft technologies. It always makes sense to improve the energy efficiency of your aircraft, because it means you need a lot less energy to power that aircraft, which is energy always costs a lot of money. It's very closely linked to the economics of flying, and also if we're looking at at the moment fairly scarce alternative low carbon forms of energy, you want to minimize the amount that you need to produce in the first place, because you've got to put in huge capital investment to build new plants and all the rest of it. So it helps, in many ways, making things more energy efficient. And we're going to do that through more aerodynamically efficient aircraft that use lighter weight materials and so on, more energy efficient propulsion systems, and more energy efficient aircraft systems, the sort of systems that consume energy on an aircraft that make an aircraft work. And then, the next of the three is to rapidly move forward technology, I think particularly around using hydrogen as an energy source. Our FlyZero study has been very powerful in looking at the feasibility of that. And we do now need to move into the phase where we're rapidly developing the technology to deliver on that. And then thirdly, there's always what we call the really important cross-cutting technologies that doesn't matter what sort of aircraft you need the sort of technology to be able to design those aircraft, because they're ever more complex than they have been before. So to design all those complex systems, to develop them much quicker, to validate them much faster and at lower cost. And the digital technology is key to that. Also bringing through digital technologies into manufacturing, much more sustainable advanced manufacturing technologies. And then there's sorts of technologies that you might employ to support aircraft right throughout their lives.
Thank you. And I think there's a really interesting question about the balance of investment between those areas. Mark, can I get your view on that?
Yeah, very good point. So, first of all, there is no right or wrong answer on the balance of investment. And that last point that Simon made is extremely important, because we often see in the different technologies we require to move the other two. So if you want to go into zero carbon emissions, or you're looking at more ultra efficient aircraft technologies, they tend to bring more complexity in the design space. We've mentioned hybridization. If you look at things like active controls or stuff like that, you're naturally bringing more complexity, and that requires the cross-cutting element to grow at the same pace as the others. So they need to evolve, and obviously the way that we put our investments to those different basically resembles our company strategy, and that's what will differentiate us between the different organizations. But from our point of view, from the Sophie and Airbus point of view, those three domains have to evolve at the same time. There is a sort of simultaneous progression on all three. We do have some sequencing in there on the number of those topics to secure certain things in one area before you can confirm the next step in another area. So there's natural sequencing that has to happen, but ultimately the level of investment needs to be pretty well balanced across those three domains.
Okay, thank you. Chris Hughes, can I just ask you, from your position within the supply chain, how are you seeing the investment playing out, and do you agree with that perspective?
Yeah, I do largely agree with it, certainly. But I do kind of reflect back on over the decades we have continued to develop aerostructures and aircraft and make them ever lighter and higher performance. And we've got very good at it. So, there's questions around, do we know how to produce high performance structures in different materials today? Yes, we do. We do know how to do that now. We know how to do it very well. Do we know how to design and package and certify hydrogen energy systems, for example? Well, actually, no, we don't yet. So whilst we do need to look across the breadth of things and keep everything moving forward, I do think we need to consider what are we already good at and what are the real gaps. But it's a difficult balance to find, for sure.
And that presumably that's a global gap, or is that just very UK specific?
I believe it is a global gap from the studies that we've done and the studies that I've read. Yeah, I think some of these technologies are well known in the space industry, but with quite a different use case. Sometimes they're just for single use, whereas we have to design aircraft to last for many years and operate many flight cycles. So we can draw on that experience, and that's what we have to do. We've talked about working internationally. We are in a race here to develop this technology in the UK, but across the world from a climate perspective. So we need to be working together and get the right collaborations and not have many little silos across Europe or across the world trying to save the same problems. We won't get there as quickly as we need to. So that just heading back to what Chris Gear was saying just earlier.
Yeah, it feels like there are two resources that we're short of here. One is money, because there's never enough, and the other is time. And so I think bringing out the collaboration point is really important. As an industry, obviously, we compete in certain areas, but perhaps this gives us an opportunity to actually grow the amount of collaboration. Chris Gear, you, when you were looking at the FlyZero project, you were looking at potentially some of the ways that we could catalyse zero carbon technologies. Can you talk a little bit about that?
Yeah, thanks, Sophie. I just following on, I think one of the things that we mustn't ignore is that there's this public perception out there, and I think you mentioned it, Sophie, and maybe Brian as well, about the negative aspects of aviation affecting the environment. And I think it's a lever that is going to change and actually start to influence more what we do in industry to try and improve our perception to the public. And it's quite interesting, last night someone made a comment about the fact they want to carry on flying. They don't want to stop flying because obviously that they enjoy flying and they enjoy going to different countries. So the challenge on us is how do we create the market that will enable that to carry on without impinging on the environment. And I think that's where, if we could, I think Brian was talking about, if we could set up the market and the economy in such a way that venture capitalists will support the argument because the public will be behind it, I think that's where we could see the disruption going on. So I may not have answered your question, Sophie, but just giving a view there. I think it's very supportive of what people are saying.
Brian, can I ask you, what innovations are you looking for within the supply chain then?
I actually really resonate pretty deeply with what Chris Hughes was just mentioning with respect to certifiability of some of these systems. I think what you'll see, and what you'll see a lot more in the years ahead, is a lot of folks have flown aircraft with new energy carriers on board. So electric aviation, hybrid electric, hydrogen. We've already, at Boeing, we've flown 5 different airplanes that have some variety of hydrogen power plant on board. But these are all prototype systems. So these are all systems that, you fly a few times and you collect very targeted data to understand something about the system. That doesn't mean that it's the wrong thing to do, because it's very valuable and you can collect data that helps to sort of push the boundaries of the art of the possible. However, that's very different from creating a certifiable system. And so I think that as these kinds of airplanes with very novel systems on board start to get towards productization, there's going to be a wave of trying to understand what does it mean to write a certification basis against one of these new airplane types, and what are the new means of compliance, and how do we make sure that they're equivalently safe with all the airplanes that have come before. And those are deep, 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 deep technical challenges that will go, it's not just an OEM subject. It's not even just a tier 1 supplier subject. It goes all the way down to the, to the bare metal of the airplane. And so, or if it is. So I think that's ultimately kind of the next wave of what you'll see, following kind of a wave of prototype and R&D and X-plane type of activity.
Thank you. I think that's really interesting, actually, that this problem is so complex and it involves so many different players. Do you think that there is enough conversation at the moment? Do you think we know enough about where potentially the problems are and the challenges?
I don't want to speak for everyone, but I would say no. From our viewpoint, I think that we at least at Boeing, I could speak. We feel that we understand pretty deeply the art of the possible from a physics standpoint. So if I change the propulsion system to a certain type, how far can I fly an airplane? How big is it? So on and so forth. But when I start to layer on the certification requirements, which are unknown, and keep in mind, these are not burdens that are levied upon us. These are things that we have to levy upon ourselves to ensure that the system is safe and is validated ultimately by our partners in the regulation community. When we start to layer those things on top, the performance that we think we might get may be dramatically different. And what is possible and realizable in a product form may be very different. And so there's a field of kind of unknown challenges for us to collectively, I think, go off and discover.
Perfect. And I mean, I'd like to ask Mark, from your perspective, who should be catalyzing those conversations?
So, yeah, I mean, this is a key part. So certainly what's been said certainly on the certification and that, yes, it's exactly right. Going to do a prototype on a flight demo or something like that is different from a certifiable product. This is absolutely clear. So this is, for me, one of the reasons why just yesterday we announced the Zero Emission Development Center. So if I look at it from a hydrogen point of view, we need the capability in order to go through those different certifiable solution scenarios, and we need to do that. And at first, we'll start on the ground. So yesterday, we managed to announce in the UK a Zero Development Center for a full end-to-end liquid hydrogen fuel system design and test facility. And this facility is taking on those challenges of certifiability and how we can produce a certifiable system, which is beyond what we are doing in the flight test domain. And this is critical. So that is really part of that catalyst that you talk about, because we need to start to play these things out in hardware, on the ground, learn and understand. It's exactly right. There's a lot of learning to go through right now. And we've got a lot of different options, solution ideas that we've got to try out. We don't have solutions yet. We've got to try them out. You've mentioned about the supply chain. We also need the support from the supply chain to help us identify solutions. There's different options, and we're constantly learning. And one of the other key things that we've touched on a little bit is the upskilling that we need to achieve. And a lot of that upskilling has to be done on the job. I can't suddenly go out and get the sort of capability we're talking about. It has to be developed. And one of the best ways of doing that is to do it for real. Obviously, we do it on ground first. So that's part of the whole story to get that catalyst going.
Thank you. And obviously, we're very, very pleased to have that investment in the UK. So thank you. A question I was asked last week, actually. In terms of investment, and I intimated earlier that I didn't think there was enough money to go around. I think that's global. I think, the size of the challenge is so large that we're going to need to reduce duplication. We're going to need to collaborate. We're going to have to think innovatively about how we use that money to develop the technologies that we need. One of the questions that was posed to me last week was, why do big companies need support with this? Can you tell me, kind of, the ATI invests in a program. We work with all of the companies that are on the screen. Why do you need support with some of these technology problems? I'll start with Mark, if that's all right.
Yeah, no, fine. So I think there's a couple of things. The funding is there. It supports not only us as an organization, but the supply chain, and it brings us together in a bigger way than potentially we can do on our own. And this is key. This is really important that we bring the full supply chain as part of these overall programs together, plus the academic community, plus the research community in country. So this is key. And that funding is what is one of those key enablers to make that happen and to bring that direction. So, the more we can do, we've got a lot of acceleration to do. There's a level of affordability that any one organization can bring. And so the more we can bring to the party, the more we can accelerate, then the better the chance we stand of getting these products, the technologies developed and the products in service in the timeframes we're talking about. And as you've already said, these timeframes in aviation speak are, tomorrow. So,
Absolutely.
And that's a significant investment from both the industrial side and the government side in order to make that happen.
Okay, thank you.
I think public-private partnerships can be extremely powerful in terms of helping to de-risk, as well as adding multipliers on top of what companies may already be investing in, but can't invest necessarily to the extent that would be required to de-risk and kind of pull things in from a schedule perspective and so on. And so I think that's a very powerful concept. I also think government has a role. I mean, we talked about, incentivizing things like sustainable fuels, but in the non-aviation dimension, this is another thing that I think is really important for us to speak about globally is our performance as an industry will be downstream from the energy grid transition. It really will be, both in terms of sustainable fuels, hydrogen. We must have renewable energy grids, or those ideas don't make sense. They actually don't improve the ultimate, environmental objective. So if you think about, who's going to transform the grid, I think the government has obviously an incredible role to play in this. And it's required. It's absolutely required in order for us to meet our objectives because we're downstream from the energy grid.
That's a great point. Thank you. Chris Hughes, can I just ask you, in terms of the government, is there more that you would want to see? We've obviously just had an extension to ATI to 2031. We've also had an uplift in our funding, which is a great show of support and a sign of commitment. But what more would you be looking for governments globally to be doing in this area?
I think from a global point of view, the governments are going to need to look at what are the regulations that really drive things forward. In the UK, we know that from 2030, we're not going to be able to buy diesel and petrol cars. And I think when the aviation industry can give the government confidence in the technology paths, then we'll be looking for the governments to step in there. But that needs to be a global thing. There's no point in doing it in isolation. I think something else that maybe in the UK, it's only the government that can do this, would be to look cross-sector. So clearly, it's not just in aviation that people are becoming very interested in hydrogen. Other industries are also looking at it from a gaseous point of view, but more and more so from a liquid point of view. So, for example, there's much to do in generating testing results for various materials at these temperatures. And back to a point from earlier, it doesn't make sense to be doing this in silos across the way. So how does the government help us look across marine, automotive, and others so that we are not developing this thing and funding these things in many different places?
Yeah, you're getting vigorous nods from the others on the panel to some of that. Simon Weeks, do you want to add to any of that?
I really like Brian's point about the overall energy supply. Because lower carbon alternatives to kerosene ultimately depend on the supply of green electricity and the grids to take that forward across countries. So that progress on that needs to accelerate. The UK is doing fairly well on its progress into green electricity, but it needs to move a lot faster, and there needs to be a balanced way of generating that green electricity as well. We can't rely 100% on wind-powered turbines, and this where the aviation industry does need to look a lot more broader, perhaps, than it has in the past about its interaction with with that upstream energy supply. Where's it going to come from, and what will aviation's place be in that future energy market will be competing for hydrogen, for example. Because there won't be enough to go around to start off with. So how will we compete for that?
Sorry, Simon, I think that the governments with legislation, if they could collaborate with legislation around the globe, they could set some parameters that would then drive some of the technology solutions, but also might bring in the private funding because they can see there's a market going to be created via this. So there is some things the governments can do. And you can see that in what's happened in the car industry where, governments have said we want electric cars by 2030. And now you can really see what that's doing in the technology. And maybe the aviation industry needs something like that as well to help drive it. And it is clearly happening because SAF has already been sort of mandated in certain areas as to what they'll be using. And I just think that the brilliance of what we've been discussing, and I love Brian's comment about it, SAF is that all the and bits are really unknowns and need lots of work, but they're all going to have a benefit maybe in 15 years' time or so, where they'll become cost competitive. And it's trying to drive all that as a unit and not duplicate it everywhere, because if we do duplicate it, then we'll just take longer to do it.
Yeah, absolutely. And I'm very sorry. We're getting to the end of this session, and frankly, I don't want it to finish. But can I just ask you, I guess, a final question? With all of the challenges we've talked about, with all of the constraints and the unknowns, can we reach net zero 2050? And I'll ask Chris Gear, can you answer that first?
I have always felt it's achievable, but it requires us to work together, and it also requires us to really drive it hard. We won't achieve it if we don't all focus on trying to get there. And I think there's been some great examples in history where people have set goals but have driven to achieve it. So you can do it, but we won't do it if we're sort of half-baked about it. So I think it's really, really important that we do drive it, and I think the public will drive it. So I certainly am on the page we can get there.
Okay. Brian, can I ask for your view?
Oh boy, this is a layup for me. I mean, I'm optimistic. I'm absolutely. I mean, since the Dash 80 and the 707 entered the market, we have improved the fuel efficiency of airplanes by 80%, 80%. It's just astounding what this industry has accomplished while making it safe, while making it accessible, while lowering costs, while doing all these things. Our same industry put people on the moon. We now have an incredible commercial space industry. We just had Starliner capsule just landed yesterday. It was really fun. We do unbelievable things in this industry. Achieving net zero, we could do it.
Perfect. And I guess, does anyone disagree with that?
Good.
Oh, look at you. Nobody's going to step out there. Okay, well, look, I just want to say thank you so much for your time. This is the kind of conversation that I really believe needs to be happening. And I really appreciate you committing and coming and giving your views. And I hope that our audience will have really enjoyed listening to it as well. Thank you very much for joining us. And I hope you found that a really informative session. It certainly started to dispel some of those urban myths and really start to get to the heart of some of the challenges that we're facing with meeting net zero 2050. Next up, we've got a break, and then we'll be back to you shortly with a conversation about the challenges of 100% SAF.